Now, it's very important here that light acts as a particle and not a wave, because a wave would supply a constant supply of energy to the electron, but we need it to supply a short burst which can be modeled by a photon. Now, if you look at this diagram here of the energy levels, you can see that we have one energy level at 4.9 electron volts above the ground state and one at 5.7 electron volts above the ground state. To move from the ground state to the 5.7 electron volt energy level, we need exactly 5.7 electron volts of energy. Makes sense, right? However, when you move down an energy level, you do not necessarily move down to where you started or straight to the ground state. You can move between energy levels, releasing photons of corresponding energy along the way. So the difference between these two energy levels is 0.8 electron volts. So when this electron moves down from the 5.7 electron volt energy level to the 4.9 electron volt energy level, it will release a photon of 0.8 electron volts. And then when it moves down again, 4.9, corresponding to the distance or the difference between energy in these two levels. Makes sense. Now, usually questions will be asked about this using the equation E is equal to hf. The energy of the photon is equal to the Planck's constant times the frequency of the wave. Remember, light is both a wave and a photon. So, knowing that here we have released a 4.8 energy electron volt photon, we can now figure out the frequency by changing this into joules and dividing by the Planck's constant.